Good morning. Welcome back. Today we are going to talk about our final polar curve. We're going to talk about the rose, and we're going to deal with the one that has 3 petals and also the rose with 4 petals. Now, there are other ways you can have even more petals than that, but in this class we're only going to deal with 3 and 4 petals. As you can see, the reason it got its name kind of looks like a flower with the flower petals here. And just like before, you might notice they're symmetrical. They will be symmetrical over the axis like before. And so the first thing I want us to notice is like r equals a cosine 3 theta or r equals a sine 3 theta. Okay, on both of those, you'll notice in the past we dealt with, or it looks very similar to the circle. Now with the circles, it was, and you might not want to write this, it's up to you. It was just r equals a cosine just theta, single theta. That 3 in there causes some things to happen, causes us to get our petals instead of just a circle. Okay. In the same way, the 2 causes us to get 4 petals. Okay. So you'll notice anytime there's 3 theta, that's going to be a 3 petal rose. 2 theta, we have to double it, and we get 4 petals for the rose. Okay. Now, the first thing we want to do is establish where does the maximum occur for each of these. Okay, so if we think back to our unit circle, okay, so on the unit circle, when we're dealing with sine, the maximum will occur when sine is 1, okay? So, because the highest, we know we talked last week, the highest value of sine we can have is 1, the lowest would be a -1. So, if we think about it, what we need to do on this is just think, when would sine be equal to 1? And that's going to occur when it's the sine of pi over 2, because pi over 2, that's straight up. Remember, sines are y, so straight up. So pi over 2. So if we had a pi over 2 in here for 2 theta, we would get 1. So all we have to do is set 2 theta equal to that. And now to get theta by itself, just divide by 2. Or you can, instead of dividing by 2, you can think of it as that's 2 over 1, so we'll multiply by 1 over 2, the reciprocal. That'll cancel. Multiply by 1 over 2, this might be easier, so we'll get theta equals pi over 4. 2 times 2 is 4 on the bottom. Pi times 1 is pi. Okay. Now, where does this occur? So it will occur, the radius will be 5 at pi over 4. That's where it will occur. And the reason we know the radius is 5, if we got a 1 there, 1 times 5, that maximum is 5 at pi over 4. Okay, so the next one, we'll do the same idea. This time, cosine of 2 pi, we're going to set equal to, the max would occur at 0, right? Because it's off to the right. So, sorry, I'm jumping ahead of the game. We still want to get 1, because 1 is the highest value we could have for cosine. The max, though, will occur at 0, because that's where x is equal to 1. So 2 pi equals 0. I feel like I should just pull up a unit circle. So let me just Google that so I can show you what I'm talking about. So, for example, the unit circle over here to the right, see, that's where our x value is 1. So that's the max. Okay. So that is why we used a theta of 0, because 0 radians. Okay. So all we got to do then, once again, times by 1/2, 0 times 1/2, and we will get, oops, man, all sorts of mistakes. That's not pi, that's supposed to be theta. I'm being sloppy, I'm sorry. Okay, so we will get theta equals 0. And if we think about it, that means, once again, our maximum is always this first number, the absolute value of that number. So 3 at theta equals 0. Sorry, I'm a little scatterbrained so far. So let's get focused. Okay, so once again, set that sign equal. So sine of 2 theta equals, now on this one you'll notice it was -2. So in order to get this to be a maximum, we would need sine to be a -1, because then when we multiply it will negative times a negative, it'll cancel, become +2. Okay, so we need it to be at -1. Now -1 occurs down on the y-axis, the bottom, so that'd be at 3 pi over 2. So 2 pi equals 3 pi over 2. Once again, it's over 1, so multiply by 1/2. Multiply by 1/2. And man, I did it again. I keep doing this. I don't want a pi there, I want theta. Theta equals 3 pi over 4. And we know that would occur. So here we have a -2, but the maximum will occur when that is a value of 2 at 3 pi over 4. So whatever that a is, that is what the absolute value of a, that's your maximum. And we figure out where it's at using this method. Okay, so our next one, cosine of 3 theta, man, not my best day, equals, now this one's positive, so we want it to be a maximum, so equals 1. Once again, that will occur when 3 theta is equal to 0. Times that by 1 over 3. 0 times 1 over 3. And we will get 0. And the maximum's 4 at 0. All right, our next one, once again, is negative. Okay, so we still want a maximum. So in order to get the maximum, we need to set this sine of 3 theta equal to -1. So -1 times -7 becomes +7. It kind of would cancel. Okay, so this will occur down once again. So down is at 3 pi over 2. Okay, now 3 is over 1, so times by 1/3. Once again, we'll times by 1/3 over here. Cancels on the left. The 3's actually cancel on the right, and we're left with just pi over 2. And so then it will occur at 7, will be the radius at pi over 2. And if you aren't sure how I canceled that out, if you wanted to instead, you could have done 3 pi over 6, which would reduce down to pi over 2 as well. Okay, our final one here, cosine of 3 theta. Man, I've made the mistake 6 times. All right, now it's -10, so the opposite of that, we need it to be a -1, so it can become positive. Okay, now the -1 for cosine occurs to the left at pi. So 3 theta will equal pi. That's over 1. We multiply by 1/3. Multiply by 1/3. Theta will equal pi over 3. Okay, so now we know the max will be 10 at pi over 3. All right, just like in the last lesson in 10.4, for 10.5 here, if you flip to the back here, I would like you to go to Delta Math and open up these 3 problems. There will be examples because we're going to graph them together. But first, let's do the same thing we just did, okay? And we didn't spend that much time on it, but remember, we said it has 3 petals if that's a 3. It will have 4 petals if that's a 2. Okay, so we look. This first one has a 3, so we know it's going to be a rose with 3 petals. Okay, so now to find the maximum. Once again, all we got to do is set that cosine of 3 theta equal to, this one's positive 5 at the front, so we know we just need to keep it positive, so we need a 1. That occurs, remember, at 0. So we divide by 3, theta will have to be 0. So at 0, and the maximum is 5. So if we go there, we're going to click on a rose, change it to 3 petals. We'll drag it out to where r is 5 at theta equals 0. So right here we got the same problem. Click the rose. Notice there's a drop down here. It's already on 3. If you wanted, you could change it. So as you can see, you could draw more petals, but for us, we'll only deal with 3 and 4. Okay. So we go here and we set it wants to be at 0, which we have, but this is at r equals 1. We need 1, 2, 3, 4, 5. So we put it right there. As you can see, it's symmetrical over the x-axis, which I'm guessing you would have expected because of this cosine. That follows our pattern we always have. Okay, so we hit yes, submit it, and we got our check mark. Okay, on to the next one. This one, there's a 2 there. So still a rose, but this one will have 4 petals. Now it's tempting to say 2 petals because it's a 2, but that doubles and we get 4 petals. Okay, now if we look here, -4 cosine 2 theta. So cosine 2 theta, because it was negative, we'll set it equal to -1 because we need those to cancel out. So -1 is to the left, that's at pi. So 2 theta equals pi. We divide by 2, so theta equals pi over 2. That's where it occurs at. And we know that it is a radius of 4. Okay, so we go the second one. As you can see, the same thing we had. We choose rows, and we need to change this to 4 petals. Okay, and it will occur at theta equals pi over 2, and we said it'd be 4. So pi over 2 is straight up. 1, 2, 3, 4, right there. All right, and we can go ahead and submit it. And we got our check mark. We're good to go. All right, the final one. This one has a 3, so we know it will be a rose with 3 petals. Once again, we set the sign part. So sine of 3 theta equal, now we're going to want to be -1 because we need them to cancel. So we get our max. Our max will be 2, we know. Okay, so -1 is down, so this will occur when 3 theta equals 3 pi over 2. Okay, so that's over 1 times by 1/3 times by 1/3. Theta equals, once again, we'll get 3 pi over 6, which reduces to pi over 2. So it'll have a max of 2 at pi over 2. So we choose the rows again. We already have 3 petals selected. That's what we need. And it occurs the max of 2 at pi over 2. So up here. And we put it right there. And we are good to go. So I submit it. And yep, I'm done. Now, one thing I want to point out on your assignment, there are going to be a few circles at the end because I want us to review how we graph circles. Okay, so if you need to flip back, I believe, let's see, that was 10.3 lesson. So flip back to 10.3 if you need to review a little bit. But that's all I have for today. Hope you guys have a great day. And if you have any questions, let me know. Do some of the ones on Delta Math because we got an assignment. Hope you guys have a great day. Bye.